Welcome to the deep dive. Today, we're going to try to untangle artificial neural networks. You know those things that sound like they belong in a sci-fi movie, but they're actually shaping the world around us right now.
Exactly. And they might seem complex at first, but the ideas behind them are pretty intuitive.
Okay, so you brought in this blog post that says it's going to demystify ANNs. I have to admit, even I'm a little intimidated, but well, let's see if we can break it down.
Absolutely. The blog post does a good job explaining the fundamentals. A good way to think about an ANN is like a network of brain cells, all interconnected, each one processing information and passing it along. The network learns from experience and adjusts its connections to get better at solving problems.
So it's like a digital brain. Instead of neurons, it has these artificial nodes.
Well, that's a great way to put it. And just like our brains, ANNs can learn some really complex things. They're what power those, you might also like, suggestions online. And they're even used in self-driving cars to help them, understand the world around them.
It's amazing to think something that complex is already in our lives. So how does this digital brain actually work? The blog post talks about comparing an ANN to a factory. I thought that was interesting.
It's a really helpful analogy. So think about it this way. The input layer is like raw materials coming into a factory. Let's say we're training an ANN to recognize pictures of cats. So the input layer would be the individual pixels of an image.
Okay, so that would be like the cotton or the wool coming into a textile factory. Okay, following it so far.
Yeah.
Then what?
Then those raw materials, they go through all these processing steps, right? On the factory floor, that's where the hidden layers come in. Each hidden layer is like a different department in the factory, transforming the data in different ways.
And those departments are set up to look for specific features, like the shape of a cat's ears or the texture of its fur.
Exactly. Each hidden layer, it applies a bunch of calculations to the data, looking for those patterns and features. Features that'll help it ultimately identify the image as a cat.
And this is where those weights and biases come in, right? The blog post mentioned them, but it didn't really explain what they are.
Yeah, you're right. That part could be a little clearer. Basically, the weights and biases are like the settings on the machines in our factory. They determine how strongly each connection between nodes influences the output.
So if the network is trying to identify a cat, the weights might be adjusted to emphasize features like pointy ears and whiskers, and downplay things that aren't typical of cats, like scales or feathers.
Exactly. And during training, those weights and biases are constantly being tweaked and refined. It's like the factory manager is adjusting the settings on the machines to make production better.
So it's a lot of trial and error at first, but the network gets better at recognizing cats as it sees more examples, and its weights are adjusted.
Exactly. That's where backpropagation comes in. It's like the quality control system in the factory. It compares the network's output to what it should be, in this case cat, and then it goes back through the layers, adjusting the weights and biases to improve the accuracy.
Okay, that makes sense. So the network is always learning from its mistakes, getting better at its job. It's like practicing a skill. The more you do it, the better you get.
That's a great analogy. And this ability to learn from experience is what makes ANNs so powerful and versatile.
But why are ANNs better at this than traditional algorithms? I mean, couldn't you just program a computer to recognize a cat? Based on, a set of rules, like if it has pointy ears and whiskers, it's a cat.
You could, but that has limitations. Imagine trying to define rules for every possible variation of a cat. Fluffy cats, skinny cats, cats with different fur patterns, cats in different poses. It would be really complex, and it'd probably still miss some variations.
So traditional algorithms are like trying to fit everything into neat little boxes, while ANNs are more flexible and can handle the messiness of the real world.
Exactly. ANNs are really good at dealing with what we call unstructured data, like images, audio, and text. It's data that doesn't fit neatly into predefined categories or databases.
And that's why they're so important for things like self-driving cars, where you have like a constantly changing environment with so many different visual inputs.
Yeah, you got it. Trying to program a car to navigate every possible scenario using traditional algorithms would be, well, virtually impossible. But an ANN can learn to recognize patterns and make decisions based on experience, just like a human driver.
So it's like teaching a car to drive by showing it millions of examples of good driving, rather than trying to give it a rule book for every situation.
Exactly. That's the beauty of ANNs. They can learn from raw data and adapt to complex situations, without needing explicit instructions for every single possibility.
It's amazing how they can find those subtle patterns and make sense of all that unstructured data. But how do we actually build one of these things? The blog post mentions a code snippet in Python.
It does. And while we won't go through it line by line, it's a simple example that shows the basic steps involved in building an ANN. It uses a data set of handwritten digits, sort of like what you'd see on a bank check.
So the goal is to train the ANN to recognize those handwritten digits.
Yes. And the code walks you through creating the network, training it on the data set, and then testing its accuracy. It's a great way to see how these concepts translate into real-world code.
I'm guessing it involves a lot of math and algorithms?
It does, but the good news is that there are tools and libraries available, like TensorFlow and Keras. They make it much easier to experiment with ANNs, even if you're not a coding expert.
So you don't need a PhD in computer science to start playing around with these things.
Not at all. There are tons of resources online that can help you get started. And even without diving into the code yourself, understanding the basic concepts we've discussed today will give you a much better grasp of how these powerful technologies work.
Okay, so we've covered the factory analogy, the importance of weights and biases, backpropagation, and how ANNs handle unstructured data. It's starting to make sense. But where does all of this fit into the bigger picture? What are the real-world implications of ANNs, and how are they changing our world?
That's a great question, and that's exactly what we'll delve into next. We've only just begun to explore what ANNs can do, and the possibilities are, well, they're pretty mind-blowing.
I'm ready to dive deeper. But before we do, let's take a quick pause so you can process all this awesome info. Okay, so we've laid the groundwork. We know ANNs are like digital brains, learning from data, getting better over time. But what does that actually look like in the real world? What are some of the exciting things happening right now because of ANNs?
One area where ANNs are really making a big impact is healthcare. Imagine a world where algorithms can analyze medical images, with superhuman accuracy, detecting those subtle signs of disease that even experienced doctors might miss. That's already happening.
Wow, that's incredible. So it's not just about replacing doctors, but about giving them a powerful tool.
Exactly. And it goes beyond image analysis, too. ANNs are being used to personalize treatment plans, to predict outcomes for patients, and even to speed up drug discovery. We're talking about potentially life-saving advancements, all thanks to these networks.
It's like having a team of brilliant medical researchers working tirelessly, crunching data, uncovering those hidden insights. What other fields are being revolutionized by ANNs?
Well, finance. Think about it. Every single day, trillions of dollars are flowing through global markets. And ANNs are helping to make those transactions safer and more efficient. They can, detect fraud in real time, manage risk for investors, and even predict those market trends.
So they're not just helping big banks make more money. They're actually protecting people from financial crime and making the system, I guess, more stable.
That's right. And in the world of business, ANNs are transforming everything from customer service to marketing. Those chatbots that pop up on websites, many of them are powered by ANNs learning to understand and respond to customer questions in a more natural way.
It's funny to think that a machine could be better at customer service than a human. What about creative fields? Are ANNs making inroads there as well?
They absolutely are. ANNs are being used to compose music, generate art, and even write stories. It kind of raises some interesting questions about creativity, doesn't it?
It does. Can a machine truly be creative? Or is it just, mimicking patterns it's learned from human work?
That's a debate that will probably continue for a long time. But no matter how you feel about that, it's obvious that ANNs are opening up a ton of new possibilities in creative fields, pushing those boundaries of what's possible.
Okay, so we've got healthcare, finance, business, even the arts. It seems like there's no limit to what ANNs can do. But what about the downsides? I know there's concerns about AI taking over jobs and maybe even being a threat.
Yeah, those are valid concerns, and it's important to have those conversations. With any powerful technology, there's potential for misuse. But I think it's important to remember that ANNs are tools. They're only as good or bad as the people who create and use them.
So it's not about fearing the technology, but about making sure we develop and use it responsibly.
Exactly. We need to think carefully about the ethics of AI, and we need to make sure that these technologies are used to benefit everyone, not just a select few.
So as we kind of wrap up this deep dive, what are some takeaways you'd like to leave with our listeners?
I think the most important thing is to understand that ANNs are already here, and they're changing the world in some pretty big ways. They're not some futuristic thing. They're powering the devices we use every day, the services we rely on, and the decisions that shape our lives.
Yeah, it's kind of mind-blowing. What can our listeners do if they want to learn more about this and stay informed?
There are a lot of great resources available online. The blog post we talked about today is a great place to start. It includes links to websites, articles, and even online courses where you can, go deeper into the world of ANNs and AI.
Sounds like this is just the beginning of a very exciting and maybe a little bit daunting journey into the future of intelligence.
It certainly is. And
Yeah.
the more we understand about these technologies, the better we'll be able to, navigate the challenges and take advantage of their potential.
Well said. And with that, we've reached the end of our deep dive into artificial neural networks. We hope you've enjoyed it. We've covered a lot of ground, haven't we? From those factory floor analogies to all the potential of ANNs, like to change healthcare and finance.
Yeah, and even with all that, it's like we only just started, this whole field of artificial neural networks, it's like constantly changing with all these breakthroughs and applications emerging all the time.
It's exciting to think about what the future holds. What are some things you're curious about when it comes to the future of ANNs?
Well, one thing that really fascinates me is how ANNs can enhance creativity. Imagine like collaborating with AI, a partner that can understand your vision and help you bring it to life in ways you couldn't have even imagined.
That's really cool, like having an AI muse pushing you to, explore ideas.
Exactly. And it's not just art either. I'm also excited to see how ANNs will revolutionize fields like medicine and research. The potential for solving problems and making discoveries is, well, it's huge.
It makes you wonder what kind of world we're making with these technologies. Is it a world where humans and AI work together to solve humanity's biggest challenges?
I think it can be. But we have to be careful, thoughtful how we develop and use these tools. We have to make sure AI serves us, not the other way around.
So it's not just about the tech, but about the ethics.
Absolutely. We need to talk about the risks and benefits of AI and have some guidelines and regulations to make sure these technologies are used responsibly.
It sounds like there's a lot of work to do.
There is, but I'm optimistic. I think we can create a future where AI makes our lives better and helps us build a better world for everybody.
Well, that's a good note to end on. Cautious optimism. I think we've given our listeners a lot to think about.
Yeah, I hope so. And I hope they keep exploring this fascinating world, the world of artificial neural networks.
Thanks for taking this deep dive with us. We'll see you next time for another one.